Hello everyone, this is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. In this video, we will see how to solve the numerical problem related to deflection. So means numerical calculation to deflection problem. So this is the first part of the video. Right? Now, so the lecture topic will be what? Numerical calculation to deflection problem and part 1. Okay, so in this part, we will see how to solve the problem. Okay, in part 2, we will take one numerical and then we will solve by using the part 1 concept. So in part 1, we will see only how to solve the problem. The same problem we will see in second video to solve. That means how to solve. So just see the question. Right? That again, calculate the vertical deflection of the point B and the horizontal movement of D in the pin joint framework shown in figure. All members of the framework are linearly elastic and have cross-sectional area of 1800 mm square. Right? E for the material of the member is given. So this is the figure, right, for the given question, right, or the whatever is given, that pin joint framework. So this also you can write as like pin joint frame work. Okay, this also question again you can find in the what, the TZ Mengson book or in NPTEL course also the same one. Right? So now E of the material is given as 2 lakh Newton per mm square. So now what we have to find the deflection at point B. So deflection at this point and horizontal movement of point D means how this will move. Okay, what is given? So again same, whatever is given just write. Like for solving numericals, whenever you are solving, first write the given data, right? Then what you have to find, write that one. So here what is given? Given is just cross-sectional area, that A value is there and it's so uniform. That is for all value is A only, means AI is not required here, and that is given as 1800 Newton per mm square. This is square, not 2 mm square, and E is given as 2 lakh Newton per mm square. Again, this is square. These two are given. Now what we have to find? What? Deflection at B. So delta B we have to find. So right, what? Delta B is what? And horizontal movement of D. So again similarly the delta B is what? So you have these two, you require this, and in the question forces are given, the where forces is acting and other dimensions are given. So this height is given as 4000 mm. This load is acting here, what, how much? 1 lakh Newton. Here from point A to point B is 4000 mm. Point B to C is again 4000 mm. Point C to D is 4000 mm. So this total distance will be how much? From here to here, that is 12,000 mm, right? One vertical force at point is 40,000 Newton, another vertical force acting in the same downward as 1 lakh Newton. Now with this we have to find what? Delta B and delta D. So before solving this problem, let's see the procedure how to solve the problem. Okay, so now this is the figure. What was in point to remember? That remove all the acting loads, right? Remove all the acting loads. So here it was 40,000 at E and here 1 lakh, right? So now just remove these loads. Now there is no load acting on this one. Then where we have to find, apply the frictious load. So here you have to find at B is apply the frictious load at P. Sorry, at B means PB frictious. So P frictious at B given as PBF. Similarly, for this, for second find, we have to find at D. So apply again, remove all the forces, apply frictious force or add one frictious force here at point D. So PDF, just to get that means properly that D is added where the frictious load is active or we added. Okay. Now next, so this is just what we splitted previous figure, that is this figure, in terms of what we required. We required what? Delta B and delta C. So at delta B, we added one fixed shear force by removing this force and this force. Okay, so for finding first at point B, just remove these forces and add here what? P F. So point B is there, PBF. Now similarly for this one, remove this again, this force, no force to act, and then horizontal it's asking in the question itself. So P D F. Right? So now after removing, so that only is given here. So for first case, finding delta BF. So at point B, just apply or just add dummy forces PF. Similarly at point D, PDF. Now what we have the formula, right, for elastic? Remember, right? I equals to 1 to K Fi Li by Ai Ei dou F by dou P. Now here in the question, what was given? A is uniform, that constant cross-sectional area is there. Now Ai is not required, right? Similarly, Young's modulus of all the members are same, means again Ei is not required. Then what we can write? Take Ai, that is A into E as common. Okay, so A into E as common, so 1 by AE. Now what is left? Fi Li and dou Fi by dou P. Now this is not required to calculate for all the parts. Means suppose 4 forces is acting, then we can write delta equals to 1 by AE common. Okay, F1 L1 dou F1 by dou P plus F2 L2 into dou F2 by dou P. Let's see what forces P is acting here. With respect to that, only the dummy force we have to differentiate. Already we had seen with respect to the dummy force or fixed shear force we have to differentiate. Dou P plus F3 L3 dou F3 by dou P. So on like that, whatever the number of forces is there, if n forces, then F3 L3 dou Fn by dou P. So now instead of this, we can write in expanded form this. So now this AE term no need to divide with the each term. Otherwise you have to calculate AE and then for each term AE first find this one and then divide by AE. So instead of that, better, so first take AE common, first find all these, whatever the number of forces are there, and then divide that value to the value of AE. Okay. Now same again from the principle of virtual work. Already we had seen this equation, integral of y dp for volume plus, that is virtual negative work, and this is because of the PR. So R equals to 1 to n delta R dou PR, that should be equals to 0, right? Now same, compare that equation, you will get. Similarly, comparing this equation, that equals to 0. Now compare this equation with what? Complementary energy equation. We see that each term represent an increment in complementary energy. The first of the internal forces, the second of the external load. So this is because of the internal force and this is because of the external applied load. Okay. The above equation may therefore be written as, same, we can write this as delta Ci plus Ce equals to 0. So now this same in terms of this, where Ci is what? Ci is with respect to the volume, that integral volume 0 to P y dP, and Ce. So this term is this one, and Ce is what? Minus of R equals to 1 to n sigma delta R PR. Now let's see here, this term is minus, right? So if this term you will take positive, then this term should be negative. So here we have taken this as positive, then this term will be negative, or else in the same way you can keep also, right? But if you will keep same form, then you cannot write in this form, because for writing in this form only Ce taken as negative and this becomes the positive. Why? Because positive here, if you will put negative, take minus common, here also minus, with this also you will get the plus, or here if plus is there, take minus common, what you will get? This term becomes minus this term becomes plus. Okay. So now after that, what we can write this as Ci plus Ce, the delta Ci plus or dou Ci plus Ce equals to 0. Where what is Ci? Integral of volume 0, another integral 0 to p d by dp. So just see here, when the double integration is there, that time it's giving the volume. This in part, that is first integration, will give you the area. If you are integrating once again, means now you have 3D, 3-dimensional. How? Just see. Like suppose here this rectangular part is there, right? This length is, take y or take x, and here a small element, that is dy, right? Then you have to find the area. So now just see, for this small element, what will be the area? Length into width. Length is how much? Dy. Sorry, this is, take this as x and this as dy of it. So now we have this rectangular area, right, having width x. Now take a small element, right, of length dy. Okay, then just see, for this small element, what will be, this is just like a rectangle. So what is the rectangular formula? Area of rectangle is length into width. If this is length, this is width, then also it's same. Or if you are taking this as length, this as width, then also area will be equals to what? X into dy. So this will y equals to x dy. If just suppose the whole area is y, then y will be equals to dy. After integrating this, we will get the area of this. So now if integrate, because just here 2 dimension is the length and width. So if you will integrate once again, now what we have, area into height is the what? Volume. LBH. LBH for any cube, volume is there. Now we have rectangular LB. Now once height will be there, that becomes the volume. So LB is what? A, and height is h. So AH means once again we will integrate with respect to the height or distance, that becomes volume. So double integration is what? Double integration will provide you volume, and first integration will give you area only. So don't confuse here why, because over, that's why here it's written what? For entire volume. Means this equation will be for entire volume. And C is what? C is for that C equals to minus R equals to 1 to n delta R PR. Okay, this is there. Next, we shall now call the quantity as Ci plus Ce. That is the total complementary energy C of the system. So here you can say C equals to Ci plus Ce, where Ci is what? Negative work done, and Ce is virtual work done because of the external load. Right? Now same, you have to find for just whatever is there. Here you can take delta 1, delta 2, P2. We can find again in the same way. So let us suppose we require to find, let us suppose that we require to find the deflection delta 2 of the load P2 in the simple pin joint framework consisting, say, of K member and supporting load P1, P2, P3, Pa, so on up to Pn as shown in figure. So here is so. So here in this question, how much P1, P2 is acting. So for this one, P1, P2, that two forces are there. Okay. Next, similarly, we require to find delta. So because of, suppose once we will find here, then this will give the delta B value, that is delta 2 value, and this will give delta D, that is in formula delta 2 is there. So for this, delta 2 will be equals to delta D. For this load, delta 2 will be equals to delta. Okay. The total complementary energy of the framework is given by, so the total complementary energy is C equals to I equals to 1 to K, 0 to Fi, Li. So just see here, their integration limit is up to Fi. If suppose fifth term, this one is there, member is there, then 0 to F5. Means whatever, for which member you are finding, that value, that force you have to take of that one. So here, that if suppose here for first member you are finding, then this will be what? Lambda 1 dF1. Second member lambda 2 dF2, means because of the force F1, how much lambda 1 is there, that we have to multiply and then integrate over the force 0 to F1. So this will be there. Next, R equals to 1 to n delta R PR. So here again for first, that is for P1, delta R, that is delta 1. For P2, delta 2. For that means for first load, first deflection. For second load, second deflection. Like that only you have to take. Where lambda is the extension of the ith member, Fi the force in the ith member, and R the corresponding displacement of rth load, means because of the PR. So if P1, then delta R will be delta 1, right? R is that particular load or that corresponding load. Now, from the principle of a stationary value of the total complementary energy will be what? Delta C by delta P2 is equals to what? I equals to 1 to K lambda I dou Fi by dou P2 minus, means just differentiate this one. So let's see how to differentiate. Okay, this term. So we are finding this one. So after differentiating with respect to what? That dou P2, because for with respect to P2 we are finding. For with respect to P1, then you can differentiate with respect to P1. So now just see here it's given in terms of P2, right? So now I am taking just as P1. So I am differentiating this as with respect to P1. So this will be dC or delta C by delta P1 is equals to, now just see differentiation and integration. So this will get cancelled because those are reciprocal of that one. So what will left here? Sigma I equals to 1 to K and then lambda I dFi by dou P1, because with respect to P1 we are differentiating, minus here again dou R. So this we can write as dou or delta 1 P1 with respect to P1. So this is P1, means simply delta P1. If we will differentiate with respect to PR, then this will be what? Or just see for this one. So dou C by dou PR will be equals to what? Sigma I equals to 1 to K lambda I dFi or dou Fi by dou PR minus, again this will be what? Get removed, differentiation. This will give you simply the delta R, because this also we can say that as integration. So after differentiating this term, PR will get cancelled and we will get as delta R. So here for with respect to differentiated with respect to 1, so we got the equation for 1. So here delta 1. If you will differentiate with respect to 2, then wherever the 1 is there, you have to just change to 2. Okay, so now how? So just see here, this is with respect to P2, means delta C by delta P2 is equals to sigma I equals to 1 to K Li, then dou Fi by dou P2 minus delta 2 equals to 0. This is identical to what? The principle of virtual forces, in which virtual forces delta F and delta P acts through real displacement lambda and delta. So for delta F, lambda will be there, and for delta P, delta will be there, right? So from here, this must be equals to 0 for equilibrium, right? Because then only the body will be stable. So this for equilibrium, the sum of negative force and the virtual force because of the fixed load should be equals to 0. Just equate to 0. Take this side, then what you will get? Delta 2 equals to I equals to 1 to K lambda I dou Fi by dou P2. Right? Now for linear elasticity, what will be there? That lambda equals to Fi Li by Ai EI. So this is for the linear elasticity. Now just see in this I am showing how this value is there. So from the Hooke's law, what is the formula? That stress is directly proportional to strain. Right? Stress is what? Sigma is proportional to Young's modulus elasticity into strain. Strain I am writing like this. Okay? Or this is the strain. So sigma is what? Okay, here just see. Sigma is force per unit area equals to, for this one, now this is equal to E into strain is what? Delta L by L. Okay, now what we have to find? We have to find this delta L. So check, cross multiply. So F into L, and this will come to this side. So by E, that is equals to delta L. So that's why it's this delta lambda is there. So instead of using here that delta L, here used as lambda. That is again the displacement. Okay, so this is from the Hooke's law only. So now for the displacement we can use what? This formula directly. Where Li, Ai and Ei are the length. So Li is the length, Ai is the cross-sectional area, and Ei is the modulus of elasticity, or you can say the Young's modulus. Both are same. That is, their name only is there, either modulus of elasticity or Young's modulus of elasticity of the ith member. So if first member, then L1, A1, E1. For second member, L2, A2, A2. On the other hand, if the load displacement relationship is for a non-linear form, say Fi, that is for linear. If non-linear, then Fi is equals to what? B into lambda I power C. So here force will be lambda I power C. So now from here we have to find the lambda I value. Okay, so how lambda I value we will find? Let's see. What we have, Fi equals to B lambda I power C. Okay, so now from here take this side. So Fi by B is equals to lambda I power C. What we have to find? Lambda I. So lambda I will be equals to, this power will be like Fi by B power 1 by C. That only substituted here. So this is the delta 2 formula, right? Delta 2. So from here also you can write delta 2 is equals to sigma I equals to 1 to K. Lambda I, what we got? P by B power 1 by C, and dou Fi by dou P 2. Okay, so this will be, that is equals to delta 2. So now after substituting, let's see, delta 2 equals to I equals to 1 to K Fi by B whole power 1 by C dou Fi by dou P2. So now in this equation, if you want to find, so first just see here that Li you have to find. If it's a linear, if it's not linear, then by this you have to find. So Li will be, for non-linear, Li will be what? Right? Fi by B power 1 by C. So non-linear case, Fi will be given, then value of B, that constant also will be given, and this power of what is there. If suppose this is just like Fi, that is 2x square. Then for finding x value, what you will do? F by 2 equals to x square. So this is root F by 2 is equals to x. So now this will be your lambda, right? Like this you can find, or just take simple word Fi equals to 5 lambda I power 4. Now we have to find lambda, right? So first we can write first Fi by 5. So this type of equation they will give you, instead of giving directly F value, they will give this type of equation, that how F is related to lambda. So this we can write Fi by 5 equals to lambda I power 4. What we have to find? Lambda I. So we can write lambda I equals to Fi by 5 power 1 by 4. Clear? So whatever the equation is given, according to that only you have to find the value of lambda for non-linear. If linear is there, directly you can use this formula. This already is derived mechanics of solid. You can find the derivation of this one, or just now we derived also, right? So that is for linear one, because Hooke's law is applicable for linear elastic property only. So from Hooke's law only I derived this one, right? For non-linear, you can use by this method. Okay, so again, these are the references from where you can see even there on this one somewhere it's cited like 5, 4, 3. Okay, so these are the citation from where you can, or from which you can refer to see the problems, or if you have any doubt. So just see again, I'm just summarizing this one once again. What is there in the question? This is the question actually, and all the dimensions is given here. 2 dimensions is not given. The 2 dimensions is what? Value of E and then cross-sectional area of these members, right? So that is given in the question as 1800 mm square, right? That is value of A is given, and that is 1800 mm square, and value of E is given how much? 2 lakh Newton per mm square. So see, one more thing. If suppose instead of Newton per mm square, they may give sometime gigapascal or Newton per meter square, different unit. Means you have to convert in the same unit. Why? Because this value is given in terms of mm. Or else, if this is in meter, then convert this into meter. So all must have the same unit. So while solving the problem, that's why I told you to write first all the given data. Here you can easily identify they are in the same unit or not. If suppose length is there, then where the length ratio or anything is there, that should be in the same unit. If it's in the same unit, then you can directly use, or else convert all the values, related values in one particular unit, and then you can use. Then final answer you will get also in terms of same unit. Okay, so now what is there? Here load is acting at E and acting at C. Now the question is, here at B load is not acting, and it's already we had seen that it's not necessary at that point also the load should act, right? So that is the benefit of this method. Even that load is not acting at B, then also we can find. Similarly at F also we can find the deflection, that is deflection of F, right? The distance of these things are given like A to B 4000, B to C 4000 mm, C to D 4000 mm. The total length from here to here is 1200 mm, right? So this is the question. Now for solving first step, what we will do? We will remove all the acting forces, right? And we will apply one fixed force at that point where we have to find the deflection. So after removing first question, what is there? That at B you have to find, right? So just remove those forces and apply one fixed or dummy load here, right? That's why it's given. Find vertical deflections. Vertically downward it will be there. Vertical deflection at point B. So here just apply PBF, the fixed load, right? Now second one is at point D. So D will move like this. So in second part, not first part, this is not required. For finding B, this one is not required. So don't take simultaneously. For finding first, only this, because it's given in question dou PF with respect to same we have to find. That is, if for finding delta 2, we have to find, that is we have to take the P2 value only. So we are finding delta B, means we have to take PB only. Clear? So don't take this also. This is just for separate one. For at first point means the load acting at that point only you have to take. Okay, so let's see. Now this is the figure here. So at this point means this load should not be there. Don't draw here the same depth one. The next figure, right? For finding D, at this only will be there. Then this time this won't be there. Clear? So in same figure, don't draw both, like don't add both PB and PDF. PBF for finding that deflection at B, PBF will be there. For finding deflection at D, PDF will be there. After that, this formula, you know, delta formula, I equals to 1 to Fi Li by Ei, Ei dou Fi by dou P. Here Ei is same for all, means we can take the common. This one there is no need to write A1, E1, A2, E2 because A1 is also same, A2 is also same for all. It's given in the cross section. So that's why 1 by E is common here. Now this is there after putting the value of lambda. So this is the value of lambda I because this is for the linear elastic one. It's given in the question itself. If it's not linear, then we will use that F equals to B P to the power C, that formula. Right? After that, from the principle of virtual work, one negative work will be there, another one will be because of that acting load will be there what you are that allowing to act that fixous load. Now after comparing with the C, what we got? It's similar to this one, and for equilibrium that must be equals to 0. What is Ci here? Ci is the for whole volume Y dP, means energy will be stored in the volume only. So for that particular volume, how much energy is stored? That is Ci, and C is what? This one. We shall now call the quantity Ci plus C the total complementary energy. So sum of these two is a total complementary energy. Once we have these two, from this only we can find the value of delta. How? So for that, same whatever is there, C is this one, right? Again we can substitute here that lambda value minus this value, okay? Then from the energy conservation, what? That must be equals to 0. So now what we have, this value, differentiate with respect to, again remember what you want, with respect to which force you are taking. If with respect to B, then differentiate with respect to PB. For D, differentiate with respect to PD. So first here that is for PB, or just as taken as P2. Here delta 2 P2. You can take here delta B, then PB. So this will be for B, delta C by delta PB is equals to I equals to 1 to K, that summation I equals to 1 to K lambda I dou Fi by dou PB minus lambda 2. That P2 is there, so that is PB. PB differentiation will be 1, that is equals to 0. Similarly for D, what will be there? Delta C by delta PD is equals to sigma I equals to 1 to K. So this will be what? Delta B equals to lambda I dou Fi by dou PD minus delta D equals to 0. So from here we will get delta D equals to what? So just see, with respect to PD you have to differentiate, that you have to remember for finding D. For finding B with respect to PB we have to differentiate. So from here delta D we will get equals to what? Sigma I equals to 1 to K lambda I del or dou Fi by dou PD. So this will be the deflection for the second part of the question, and this will be the for the final. So same will be there, just which point you are considering. That point, that means at that point what is the force acting, that you have to take. That's why I just taken the normal delta 2 P2. So here delta B PB, delta D PD. Okay. Then next put the lambda I value, right? Lambda I is Fi by Li, Fi Li by AE. That is for linear one. Okay. If it's non-linear, then F will be in this form. Fi equals to B of lambda I power C. That already derived. From here, this is for non-linear one. So from here, you can find lambda I. That lambda I will be what? F by B power 1 by C. Now put lambda I here or in this formula. In this formula only. If it's non-linear, part is there. So after finding that, what you will get? Delta 2 equals to I equals to 1 to K. Fi by B whole power 1 by C, okay, dou Fi by dou P2. So for B, this will be delta B, I equals to 1 to K, Fi by B. That B is constant, not that particular point B. Power 1 by C according to the given question. If suppose the same I given example, right, that F equals to 5x power 4 or 5 lambda power 4. From there you can find here and you can substitute, and then here this will be dou Fi by dou PB. So same thing you can go for the D also. So for solving this, what we will do, we will use the tabular form. How? Just see here. I'm showing you the tabular form. What we will see in the next video to solve. Right? This is the question, and after this we will make this table. Right? How to make this table and how this will help, that we will see in the same question is there what we had seen. Right? Same question we will solve in the next video, and by using the tabular form, and after that we will see how to solve this problem. So for this solving one problem will take one full video. That is not that much easier, that we cannot directly form this table. Right? So for find this table we have to find all the values L, F, FB and everything we have to find. Right? So that we will see in the next video. Right? For this one, till this only just to find the deflection. Now how this will used for the given problem, what is given in this first slide for this question. So this question we will solve in next video. Thanks for learning with this video. If you have any doubt, you can just comment on the video section, or you can ask me related to any doubt if it's there. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.